Welcome back to all those who have been following through our videos, and also welcome to the newcomers. Now we are moving on to part C of this past paper, which is from May 2016, question 11. And we are required here to basically find the inverse of the matrix. So in the previous video, we would have covered the other part. So we have matrix N, and we need to find its inverse. So we have, well, of course, you needed to find the determinant, followed by the adjoint matrix, right? So you see I have 1 over 5. How did I get that? Well, we did determinants already, where you usually have A multiplied by D minus B multiplied by C. Right, so it would have been 4 multiplied by 2, which is 8, minus 1, 3 is 3, which would have given you 5, right? So that's why we have 1 over the determinant, which is number 5, and then we basically would usually use the adjoint of the matrix and multiply it by the determinant. So what I would have advised you all to do was to find the inverse of matrix N, right? And the inverse is usually just the fractions that I had in the brackets there, right? You didn't have to put back the 1 over the 5, right? Just the fractions, right? So when you are using simultaneous equations to, well, matrices to solve simultaneous equations, you still to find the inverse of the coefficient matrix. Now, what I'm stating here would have been done at least once previously in a separate video. So, of course, you can go back to the matrices playlist and be able to find that. So, now what I'm rewriting there is the coefficient matrix, which is 4, 1, 3, 2. I also have a video on coefficient matrix, then the variable matrix xy, and the answer matrix 1, 2. And since I would have found the inverse of the coefficient matrix, which is the first matrix is written there, now we need to multiply both sides of that matrix equation by the inverse matrix, right? So at this point you would see me writing in that information. So what is being written right now is the inverse matrix. And again, we have to multiply this on both sides of the matrix that's on top. So we have to rewrite the entire thing. Now, if you're wondering why it is I'm writing the inverse equation on this side of the equal sign before the matrix that has 1, 2, is because that's the only way in which, or position in which a 2 by 2 matrix will be multiplied by 2 by 1 matrix. And if you don't know how to identify orders of matrix, then you need to go and check my video on orders of matrices, right? Because you want to be as clear as possible and understand the foundational concepts, right? So I have the inverse matrix, which is n negative 1, n, which is basically the coefficient matrix, v is for variable matrix, n minus 1 again is the inverse matrix, and then we have e, which is the answer matrix, right? Now, I actually took the time to work out everything because I wanted to prove something to you guys, right? So what I'm going to work out, once you understand this, you would not have to work out certain parts of that last line that I just wrote there with all the matrices, right? So when you multiply the inverse of a matrix by the original matrix, you would always get the identity matrix. And that's something you have to learn and remember. It will save you a lot of headache and time in matrices, right? And as I said, I would obviously do the working so that you all can see for yourselves, right? So I'm going to multiply 2/5. Well, of course, you always take the first row and the first matrix by the first column in the second matrix. So 2/5 by 4. And this what I'm doing right now. You will not have to do this if you learn that same concept and save yourself so much time. But I'm just doing it to prove to you that what I'm saying is true. So that you can see for yourself and not be doubting, right? And then -1/5 by 3. So as you see, I'm changing colors anytime I'm changing in terms of what I'm going to multiply. So the first row of the first matrix now is going to be multiplied by the second column of the second matrix. So it's going to be 2/5 by 1 plus -1/5 by 2. The first column of the second matrix would be -3/5 by 4 add 4/5 by 3. Now we're going to multiply the last row or the second row of the first matrix by the second column of the second matrix, which will be -3/5 by 1 plus 4/5 by 2. And if you all realize, I am breaking down this stuff to make sure that you all understand what you are doing. And again, this big piece of work that I'm doing right now, I'm going to prove to you all why you wouldn't have to do this. If you understand that an inverse matrix multiplied by the original coefficient matrix that you found the inverse of will give you the matrix 1, 0, 0, 1, which is the identity matrix. So now we multiply, right? 2 4s are 8/5 and 1 negative, 1 3 is 3/5, right? 2 1s are 2/5, add -1 2 is 2/5. So we simplify it, and I'm supposed to get my final answer to be 1 0 0 1 identity matrix. I keep saying that because I wanted to stick in you all's head, right? And of course, if you all would like to have extra classes, you can definitely use the registration link in the description below. So -3 4s are 12/5, add 4 3s are 12/5, and -3 1s are 3/5 plus 4 2s are 8/5. When you have two signs being right next to each other, like the plus and the minus, a minus by plus is a minus, right? So it would become a single minus sign. And we could go ahead and subtract the fraction. So 8 take away 3 is 5/5. 2 take away 2 is 0/5, or 0, of course. -12 add 12 is 0/5, which is also 0. And -3 plus 8 is 5/5. And of course, you all who are so good at fractions, you all know a whole fraction consists of the same denominator and numerator, right? So 5 divided by 5 is going to give us 1. Why did I just write 5 below? I think that was an error there, but I definitely will have to fix that right now. Okay, great. So we have 1 0 0 1. I'm not sure why I got the negative sign. Most likely I did something incorrect, but it seems to be the one seems to be positive. So you see, I got the identity matrix. So you know what? Anytime you all are doing this simultaneous equations, but they're using matrices to solve it, when you reach this step where you have the inverse being multiplied by the um, coefficient matrix, you just replace it with 1001 and you don't have to do all along working, and it saves you so much time, right? Because it doesn't matter which inverse matrix it is, and a matrix by its inverse will always give you the identity matrix. So once again, the n inverse by matrix n will give you 1001. So now you're not confused how I got it right. You saw the process. And then we write back the variable matrix xy. And the only thing you really should be multiplying is the inverse matrix by matrix A, which I'm about to do right now. So that's going to be 2/5, -1/5. Well, of course, row by column, right? So 2/5 by 1 plus -1/5 by 2. Then row by column again. So the second row by the only column, -3/5 by 1, add 4/5 by 2. And then we simplify to find our final answer. 2 by 1 is 2/5. We could, in this case, I'm getting rid of the signs one time, right? So a minus by plus is a minus. 1, 2 is 2/5, right? So you see I did these signs the second time the previous time, and now I'm doing it first to bring it to one side. Then we have -3/5 by 1, that's -3/5. Plus 4 twos are 8/5. 2 take away 2 is 0, and 5 take away 5 is 0, so that's 0, right? And then we have 8 take away 3 is basically going to give you 5, or -3 plus 8 is 5/5, which is 1. So the answer is 0, 1. And it really means that the value of x is equal to 0 and y is equal to 1. Now, another thing you'll need to know is that you see I'm underlining there the identity matrix multiplied by any matrix will give you back the matrix you multiply the identity matrix by. And I did a video on this separately, right? So again, check the matrices playlist if you're not clear on that. Or I have a full example. If I multiply those two matrices there, I would get xy as my answer. Some of you all would know like 7 twos are, not 7 twos, like 7 by 1 is 7. That's the same thing. So that identity matrix acts like 1. Like any number multiplied by 1, you get back the number. 9 ones are 9. That's technically what it does. So again, the final answer for x is going to be 0 and the answer for y is going to be 1. And when you reach this point, you have finally and successfully completed the problem solving for using using matrices to solve simultaneous equations. I hope that this matrices series of videos was really helpful and open your eyes to things you never saw and understood in matrices. And make sure to share, subscribe on or if you haven't as yet, and of course look forward for more videos. Okay, you will be blessed. And if you need that extra classes, check the description or comments and register. Bye.
Thank you for viewing.